thanks so much for joining us, everyone. We're really excited to have you here. This has been a long time coming, a lot of work on both the Formlabs and Fusion side. So we're really glad to be here so we can talk through this exciting integration and partnership. So yeah, basically, I'm going to give a short presentation to start, sort of introducing Formlabs to anyone who's not aware of us and what we're about. Then I'll pass it off to Jack, who will do something similar for Autodesk and Fusion, and then he'll discuss the specifics of the integration a little bit more. Then it'll go back to me for a second, just to show off our software side of things, what happens after you export a model from Fusion. And then at the end, we'll have some time for Q&A. So yeah, I'll get started in just a second, but I'll also say, please feel free to leave questions in the Q&A box at the bottom of your Zoom window throughout the presentation. Yeah, and we'll get to them at the end. I'll just say if it's convenient, just put who you're asking, whether it's Formlabs or Fusion, at the beginning of your question, just so we know who it's directed at specifically. That's helpful, just so we keep everything straight. But yeah, let's get into it. So yeah, we're Formlabs. My name is Dan Kirschgester. Like I said, I'm the community manager at Formlabs, so I interact with big groups of our users, like all of you. I'm really excited to be here today. The Formlabs mission is really simple. Formlabs is expanding access to digital fabrication, so anyone can make anything. And we find that the anything part of that comes up a lot. How do people deciding what would they want to make? How do they make it? What software that should they use? And so if we can remove some of those hurdles and make the process a little more streamlined by working with Autodesk, then that very much syncs up with our mission. Also say I have kind of a stack of slides, and I may move through some of them pretty quickly. I think a recording of this presentation is going to go out afterwards. And also, if you notice something and you want me to get back to it during the Q&A at the end, just put that in your question. I'm happy to go back. So yeah, Formlabs is an SLA 3D printer company. To date, we've printed more than 85 million parts, shipped more than 75,000 printers worldwide. We have more than 550, it's probably closer to 600 employees worldwide now, in a bunch of offices all around the world. We're headquartered in Boston, in Massachusetts, but we have offices in Berlin, in China, in North Carolina, in Ohio, all over the place. Basically, our thesis as a company is to take as much of the performance from a very high cost printer and combine that performance with the cost of a low cost machine. So what we do, the way we do that is by taking a lot of off the shelf parts, and with a lot of very complicated, brilliant engineering, we're able to take cheaper parts but make them perform to the same level as a more professional, or I would say a more expensive, larger machine. We make all our own products all the way through the vertical slice. So we make our hardware, we make our software, and we make all of our materials in-house as well. We have a pretty big line of products from the Form 3, which is sort of our meat and potatoes workhorse machine at Formlabs right now, up to the Form 3L, which is a larger format of that same Form 3 technology, a 5 times larger build volume. We also have the wash and cure, which are part of our post-processing system. And then very recently, we released the Fuse and Fuse Sift, which is our SLS printer selection. I'll go through this slide pretty quickly, but this is just a smattering of some companies that we work with and who use our printers for a huge variety of things. And I'll get into some of our industries later, but it's a pretty good row of companies that are doing amazing things. So we're really proud to work with all of these guys. So really briefly, introduction on 3D printing. When most people think of 3D printing, they think of what's called FDM. You can see it there on the left. It's essentially taking a spool of hard plastic, running it through a heated head. That head distributes the plastic in layers on a build volume. And then it builds up layer by layer by layer until you get a complete part at the end. It's a great technology. It's good for a lot of things. Formlabs focuses on this middle section here, the SLA part of it. So we take a UV laser pointed at a resin that has some photo initiators in it, some polymers that react to or some monomers that react to UV light and become polymers, a more solidified solid part at the end. There are a bunch of different options for materials you can print with all sorts of 3D printers, but we focus on thermosets. You can see there on the left, thermoplastics are what I just mentioned FDM using. So that's a hard plastic that can be melted and then resolidified again. Thermosets start as a viscous fluid, they're cured to become solid, and then they cannot be returned to those component parts of a liquid again afterwards. They've been fundamentally changed. So yeah, we use SLA or stereolithography. Here's a nice little diagram of how the Formlabs machines work. So I'll just really briefly talk through this. So you have the part hanging from the build platform, which is what's labeled as number 4 there. You have a tank of a thin layer of liquid resin, usually about a ½ inch of liquid resin. That's number 3 in the picture. And then between number 3 and number 1 in the picture, which is the actual part, you have a very, very thin layer of liquid resin, and a laser goes around that layer, solidifies that gap between the part and the bottom of the tank. Then the platform raises up, and the whole process repeats over and over again, several thousand times until you get a complete part. A lot of detail on the slide, not going to go through all of it, but just to say, like I said, the Form 3 is our sort of main workhorse printer. Like in the movies, if they go to the bar and say, give me a beer, if you came to us and said, give me a printer, this is what we would give you. It's an amazing machine. It produces some incredible parts. I'll show off some of those later. We also have the Form 3L, which, like I said, uses the exact same technology as the Form 3, but instead of one optical engine, or the LPU as we call it, it uses 2. They sort of meet in the middle like that. And it does a 5x build volume to the Form 3. So if you need more parts in one print, it's a good solution. Or if you need to do, single larger parts, it's a great solution for that as well. Now I'll talk through our total workflow a little bit. As you can see here, from produce a file to choosing a material and layer height, preparing the model in preform, printing your model, and then post-processing. It's a big selection of stuff, but overall pretty simple. I've underlined the produce a 3D file because that's a lot of where our focus is today. Just to very quickly, the wash it and the cure, which I mentioned earlier, they're pretty important for Formlabs resins because heat and a UV oven essentially at the end of the print process is required for a lot of our materials so that they can reach peak mechanical properties. Meaning if you have a strong material that's meant to be strong, it won't reach its peak strength until it's been heated and cured for 60 minutes at 70 degrees C, for example, which the wash is able to do. So now I'm going to run through our portfolio of materials. Again, there's a lot here. I think we're approaching 30 or over 30 at this point total, but a good selection of standard ones. So we'll start top left, which is our standard resins. These are a good happy medium of strength, ease of printing, ease of post-processing, all that kind of stuff. This material comes in clear, white, gray, or black, or color, as well as draft, which is our high-speed resin. We also make some medical resins here, Biomed, Amber, and Clear. They have gone through FDA certification so that they can be used in a medical setting after they've been printed. Similar to that, we have dental resins. They've been FDA certified so that a lot of these can go from a printer into obviously a cleaning solution or an ultrasonic cleaner and then into a patient's mouth. So that's why you see things like LT Clear here, which is like a long-term retainer, or a denture resin. So while these may look like models, they could go from the printer into a person's mouth, which is pretty amazing. If we move down to the bottom left there, we see our selection of engineering resins. There's a bunch here. A lot of them are designed to mimic other materials you may use in your manufacturing processes. So the tough materials on the left there, for example, might mimic ABS plastic. Durable mimics polypropylene plastic. Flexible is a good vulcanized rubber analog, and elastic is elastic. It's very stretchy and cool. We also have things like high temp, and then rigid, which is a glass infused resin for making really, really stiff, clean lines, things like that. And then lastly, here at the bottom, we have castable wax and castable resins. So these are resins that have a wax content in the material. that means they can be burned out in a burnout process like you would if you were using a traditional sculpting wax to produce jewelry. So really, really cool and awesome use of our machines that we really love to see. And then briefly, I'll just cover the SLS selection. This is the Fuse 1. It released just a few weeks ago, like a month or two ago now, so still pretty new for us. We're really excited about it. It's an incredibly strong, durable material that can be used for a lot in the prototyping world. And I'm really excited to see where this goes. I'll mention that while the Fuse and SLS integration is not in Fusion yet, it is something that I know Autodesk is really looking to put in there as well as a companion piece to the SLA stuff that we have in there right now. Software, like I mentioned, we make our own software called Preform, which is our print prep software. I'll show that off a little bit in a few minutes. And then we also have what's called our dashboard, which is an online hub where you can track your prints. You can track a bunch of printers, who's using what, who's printing when. You can start prints, give people permission to use printers or not, all sorts of stuff to help you manage your printing time. Also to add on, just resources we have out there, and I know I have some fellow Formlabs employees who are watching who wouldn't mind dropping a couple of these links into the chat if anyone is curious. But we have a lot of learning resources out there, including some that we've made that Jack had a huge hand on for Fusion specifically. So some PDF guides on how to best design in Fusion to eventually get to a 3D printer like Formlabs. Quickly, just going to run through some of the industries that we're involved in. Maybe something here will spark your inspiration or curiosity about what 3D printers are capable of, which is what we like to see. Here's a big overview, but I'll go through these more specifically. So engineering, manufacturing, and product design is our main sort of bread and butter industry, vertical, if you want to call it. That's where we put a lot of our energy, not all of it, absolutely, but it's our main sort of industry. So rapid prototyping, making a lot of iterations of a particular part, making jigs and fixtures for your manufacturing process, things like that. Like I said, dental, another really big one for us. I won't linger here too long because you can sort of intuit what dental is. But it's a really an almost equally large business for us, and a cool one. So if you're curious about dental, let us know and we'd be happy to go into more detail. Healthcare as well. So surgical planning models, orthotics or prosthetics, medical devices and surgical tools. All of these can be used either with those biocompatible resins I mentioned, or if it doesn't need to be in contact with human skin, for example, your options are a little more broad, but a lot of cool uses in the medical field. Jewelry, like I said, you can do vulcanized rubber molding, investment molding, and yeah, custom jewelry. It's really exciting and cool. A lot of resources on our website about how to dig into jewelry if you're curious. Another big industry for us is education and research. So things like microfluidics, maker spaces and fabrication labs at schools, or medical models, things to visualize, parts of the human body that are really hard to talk about or see when they're not in 3D. We think 3D printing gives a lot of freedom to show that stuff off, which is really cool. Another really exciting one, arts and entertainment. This is one that I'm personally really excited about. Everything from Marvel movies, you can see the Stranger Things Demigorgon here, model makers, toy designers, all sorts of cool uses in the entertainment field. If anyone has pretty sharp eyes, you can see our printers in the backgrounds of a bunch of different Marvel movies. They sit there both as set dressing because they look like they belong in a cool lab, but also those same printers were used to produce props that were used in those movies. So really, really cool. And we're always really excited about that stuff. Audiology, another one for us, custom molded ear designs, things like that, what we call kind of high volume customizability. And lastly, we'll get into this as we go, but I just wanted to highlight the integration website that we put together with Autodesk and Fusion. It's been an awesome experience. There's a lot of really cool resources on here. Like I said, you can request this amazing sample part, which Jack can talk about more in a few minutes. You can look at the design guide. You can look at some awesome customer stories, which I'll get into right now. So on the website now, I'll just give a brief description of these. COSM is a really amazing medical device that's for making what's called pessaries for uterine prolapse in women. They're doing a lot of really, really tight design work in Fusion with a lot of really minute adjustments for to make a model work for the particular patient. And yeah, they've been an amazing story for us. And we're excited to see more with them. So like I said, anything I'm mentioning here, we have a big full blog post that I would highly recommend you go read because it's a lot of interesting stuff. Vertiball is another example. It's a muscle massager that you pin to your wall, you suction cup to your wall. You sort of lean up against it and work out knots in your back and things like that. This was done in the Fusion 360 simulation system. So they did a lot of the kind of testing forces and things like that. And then at the bottom here, we have Print City, which is a UK-based 3D printing design hub. And they're doing a lot of work with United Utilities in the UK to sort of work on some valve upgrades and things like that. They've been doing amazing work both in Fusion and with Formlabs printers. So yeah, we are really, really excited and thrilled and thankful that these guys all talked to us and gave us their stories. And we hope to expand on this more and talk about more cool joint projects in the future. So with that, I think that's it for me. Thank you for listening to me talk like that, and I'll pass it over to Jack, and then we'll go from there.
Yeah, thanks very much, Dan. Sorry, I just lost where Zoom was.
No worries.
Too many minutes. Hopefully, what's going on here? Ooh. Okay, there we go. Should be seeing PowerPoint now.
Yep, looks good.
Fantastic. All right, yeah. Well, thanks, Dan. Thanks for that brilliant overview of Formlabs there. Just very quickly, my name's Jack. Thanks again, everybody, for joining. I am a technology consultant with Autodesk, working kind of primarily on Fusion 360. And so I'm just going to talk to you briefly now about what is Fusion 360 for those of you who might not be aware. And then we'll have a look at this Fusion and Formlabs integration, which Dan's already explained a bit. We'll jump into the software and see exactly how that all works. Very quickly before that, just a brief bit of background on Autodesk as a whole. So for those of you who might not know, Autodesk is a kind of global software company, and we produce a whole range of design and make software products. We operate in a very wide range of industries as part of this, so everything from kind of consumer products to transportation, heavily involved in architecture and construction. So even if you aren't too aware of Autodesk as a company, there's a good chance you would have heard of AutoCAD, involved in things like industrial machinery, and then even like the entertainment area as well. So kind of movies, special effects, video games, this sort of thing. And across all of these industries, we have a kind of common slogan, a common mantra of, with the use of our products, enabling our customers to do more, better, and with less. And this is what the idea behind Fusion 360 really is. So Fusion 360 is a design and manufacturing software, and is not just a CAD software or a CAM software or simulation, rendering, ECAD, 3D print preparation software. It's all of these things all wrapped up in one. So here we can see just some of the capabilities that we get with Fusion 360. So there's various modeling techniques that we can do, for example, freeform modeling, parametric modeling. We can work with meshes, which can be very useful for 3D printing workflows. We can carry out simulations, we can do CAM work, obviously including additive 3D printing work, create things like 2D documents, renders, all within this one package. And the fact that they are all connected also aids with collaboration by kind of connecting the different teams that work on these different stages. That collaboration is also aided by the fact that Fusion 360 is a cloud-connected platform. And all that this really means is that when you create a Fusion 360 file, when you kind of save a project, this gets saved to the cloud. So it gets saved to your Fusion account, meaning that you can then access these files, access your data from any device, anywhere, anytime. And we say any device because Fusion 360 is device independent, so it can be used obviously on a kind of desktop PC, a laptop, but also on things like tablets, smartphones, etc., to still access this data as well. The fact that it is cloud connected also opens up the opportunity for cloud collaboration as well. Because the data is saved to the cloud, we can very easily share this with others, meaning that others can not only view this, but also work on it and collaborate on files. Also being able to access this anywhere, anytime, and vice versa. People can obviously share files with yourself, so you can gain access to their data or your shared data anywhere, anytime. So we'll have a quick look now at just some of the capabilities within Fusion 360 that aid with the kind of design to 3D printing workflow in particular. So first of all, we have a few different modeling techniques for the concept development stage itself, so the actual creation of our designs of our models. So we have something called freeform modeling, which helps us to easily create complex surfaces using what's called T-spline technology. And this essentially involves manipulating surfaces, edges, vertices by pushing and pulling on these, similar to kind of sculpting clay. You can almost think like this, just obviously within the kind of CAD environment. But it means that you can really quickly kind of create these more free-form, organic, complex surface shapes, which aids with rapid ideation, rapid iteration of design ideas, which can be particularly useful in the kind of 3D printing workflow where we're printing something, going back and changing it a bit and going through that kind of cyclic workflow there. We've also then got parametric modeling, which is more of your sort of typical modeling technique. So this is where we are inputting specific geometries, specific dimensions, and creating solid models from those. And we can also then do this parametrically. So this means that rather than just inputting everything as individual dimensions, we can set these up to use parameters, which can also link to other parameters, meaning if we want to edit a model, rather than needing to go in and change every dimension, every feature, we can simply edit the value of a parameter or a set of parameters, and this can update the entire model or parts of a model automatically according to those changes. This is all also history based. So what that means is just that every kind of feature that we create, every item that we put in there goes into a timeline of the creation of this model, which means it's really easy to jump back and forward within that timeline to make edits, which will then update throughout the timeline, kind of where appropriate. Then got a couple more methods of modeling again. So we've got freeform modeling, direct modeling, sorry, another method of freeform modeling, which is less about using the parameters and more about just making adjustments to the solid models directly. So these can be solid models that have been created within Fusion 360, but it's also very easy to edit non-native files. So CAD files which may have come from other packages. So Fusion 360 has the ability to import over 50 different file types. And then once within Fusion, these can be worked on as if they were created in there, very easily changing features, changing surfaces, etc., which can be very useful for obviously taking designs and then preparing these for 3D printing. Similarly, with meshes, we can import these, edit and repair these in order to prepare those for our 3D prints as well. Once we have our design, our model, however that has been created, we also have the ability to then put these through a simulation in order to analyze the potential product performance of a design. This is so that we can obviously check that a design is going to perform as it needs to in a kind of given application without needing to go through the entire manufacturing workflow. Obviously, very beneficial to do this within the software, linked with the design, so that if something is found to not perform as it needs to, it's incredibly easy to go to the design, make a change, re-simulate, and again, iterate in these stages here. You can see in the capabilities there's a list of some of the different simulation types we can run, and also mentions there the ability to cloud solve as well. So this is another really great benefit of having Fusion 360 cloud connected, that we have the ability to push a lot of these computations to the cloud to happen there, rather than kind of relying on our PC's computing power and tying that up. Instead, we can run various computations simultaneously while carrying on with other work. Then once we have our design and we're kind of happy that it's what we want, we're obviously then interested in manufacturing this somehow, which can all be done within Fusion as well. And this is where we come to our Formlabs SLA integration. So effectively, what we have done is taken the Formlabs SLA printers and put those inside Fusion's machine library. And we'll have a look very soon at exactly what that means. But this really opens up the ability to then use SLA technology within Fusion. These Formlabs printers are the first SLA machines to go in. So Formlabs are very much leading the way with us on opening up that technology within Fusion. And within there, as we'll see very soon, we can then set up the prints all within Fusion again. So we can position these, create support structures. And then once we have all of that set up, we can push this from Fusion over to Formlabs Preform for those final few stages of slicing and then making any tweaks to the setup that may need to be done. So with all that being said, I will now jump over into Fusion itself and we'll have a look at exactly how this integration workflow all works. So we'll see here this, our Fusion 360 window. At the moment, we're just looking at a blank document. And I just very quickly wanted to explain the kind of cloud storage, cloud collaboration side to you. So over on the left-hand side here, we have what's called the data panel, which is where I can just access all of my cloud data, so my various Fusion projects. This works in a very similar way to just a PC file explorer, where we can create folders and folders within folders and then put our kind of various files in here. And from this location, we can also very easily then share these projects with other people. So what we need to do is just enter somebody's Fusion 360 address into here. They'll be invited into the project and they'll be able to not only kind of view and open that data, but also work and collaborate on that as well. So I'm going to open up this project here, which is this sample part, which Dan has kind of already hinted at a little bit. So this part is actually a desk hook. So this was designed by one of the team members over at Formlabs. And this is just something that you can kind of attach to the side of your desk to hang your headphones on or any other kind of appliances, wires to help declutter that a bit. And this is what we're going to have a look at setting up to get ready to print on a Formlabs printer. So I see here that we've got the actual hook itself, which is this kind of F-shaped part. And then we've also got this screw within there as well. So that screw has not actually been directly modeled up within this file. That has instead come from the McMaster-Carr component library. So this is something else that we've integrated into Fusion. So McMaster-Carr are a large supplier of these kind of standard parts, screws, bolts, nuts, washers, you name it, they are going to supply it. And what this means is that we can come into this library, kind of grab these standard parts from here, which saves needing to model them up ourselves. It means that we're sure that it can be modeled up to the correct sizes, and we can also order it directly through here as well. So that is where that particular part's come from. Because it is just a standard part, we're obviously not then going to 3D print that. So I'm going to turn this off, and we're just going to focus on our actual hook body here. If we then have a look down at the bottom of our design window, we will see the timeline. So this is that kind of history-based modeling, which I mentioned a minute ago. So we'll see here that every kind of item, every feature which was added onto this model is added to our timeline, whether that be a sketch, fillet, an extrusion. And it makes it incredibly easy to come back in and effectively jump back in time, make an edit to a feature, change a dimension, or change how an operation is working, and then jump back to the end of our timeline, and those changes will be applied. So for example, I'll change one towards the end just so we don't break anything, but I can easily jump into that fillet and just change the dimension of that. And you'll see how the kind of surrounding geometry updates accordingly as well. And this is something else that really helps with that collaboration side of things. So I did not model this up myself, but I've still got access to that whole timeline. So it means when I open this up, I can see more or less how this model was created. And it also makes it incredibly easy for me to make adjustments to that as I wish, really. So once we've got our design kind of ready to go, the next stage is obviously now to set up our 3D print. So to do that, I'm just going to jump out of my design space here over to the manufacture workspace. And you'll notice that the ribbon at the top changes slightly. I've got some new tools on offer, and I'm currently in the additive tab. So there's a few other manufacturing techniques I can choose from. Obviously today we'll just focus on the additive side. The first thing that I'm going to do is define my machine that I'm going to use, my printer. So I'll open up my machine library here, and in the Fusion 360 library, so this is the machines that every Fusion user has access to, you'll see that we have a fairly extensive list of printers here. I can kind of scroll down to my Formlabs ones. I could have searched in here, and we can also filter by technology type as well. So if I select just to see those SLA printers, I'll see just my Formlabs on offer here. These are all ready to go. I simply just need to select the model I want. We'll go with the 3L. And you'll see that it brings the model then of the kind of build plate into my document. So we'll accept that, and we'll see that it's automatically kind of placed my part within the Formlabs printer environment now. So obviously incredibly useful to have the exact size, the exact kind of geometry of this build plate, so that we can set up the print exactly as it will then kind of occur on the printer itself. So if we have a look at this, it is within that kind of area, but it's certainly not orientated in the best way. We've got a lot of empty space here. So the next step is then to kind of position this a little bit better. I could do this in a few different ways. I could just manually move this myself, just kind of as I see fit, so we can easily translate that, rotate that around, for example. Or I've got a couple of more kind of automated options. So for example, we have minimize build height, which will do just that. It will just take the part and reduce the height as much as it can, which with SLA prints is quite beneficial, as the build height is quite directly related to the build time. Or another option that I have is this automatic orientation one, which I'm going to use. And what this does is it will look at our part. We can change a few settings. So let's tell it to go a bit closer to the platform. And then I have some criteria here, which I can rank in importance, basically, to get Fusion to kind of orientate this for me. So for example, I'm going to change the support volume to high, which is telling Fusion to prioritize using less support volume. I want to reduce the amount of kind of wasted material here. The support area and bounding box volume, I'm not as focused on. We can set those as low. And then part height, I'll put up to high. Again, preference to kind of reduce that part height where possible. So we can accept that. Just give it a few seconds here to have a think about it. And then we can go in and view these results. So as soon as I open this up, you'll notice that the part is reorientated into kind of a much better position now. It's much closer to the platform. And if we look in here, I've got a fairly long list of different orientation options now, which have been calculated based off of my rank and those parameters which I set up. As I cycle through these, they're effectively ranked in order. So number one is the best orientation according to my ranking, and then getting less optimized as we go down the list. But you'll see as I select each one, we get a preview of that orientation, and we can also see the kind of statistics of those criteria as well. So we're not forced into any one particular orientation. Generally speaking, if we set up our ranking as we really need it, then this top one will be what we want. But you do have the option to sort of cycle through those other alternatives and pick the best one. I'm going to stick with that top result. Okay, and now my part is much better positioned. So next, I'm going to keep going along my ribbon here, just as a bit of an aside. With Fusion 360, really nice and easy to use. Generally speaking, we just have a kind of left to right workflow down our ribbon here. Just need to step through setting things up as need be. So coming from left to right, the next thing that we have is the print settings. I'm not actually going to change anything in here because by default, when we pick a Formlabs machine, it's going to assign Formlabs kind of specific settings to those. So no real need to go in and change that. So I'll skip over that step. And the next thing that we have, which I will want to set up, is then creating some support structures. So in here, I've got a range of different options. These are all just slightly different geometries of support, essentially. Which one you go for depends partly on the application, partly on personal preference, really. But generally speaking, this lattice volume support is a good balance of kind of support strength versus material use. So I'm going to go with that one. And now this is really easy to kind of define how I want to support this part. Just need to tell it what I would like to support. In this case, we'll go for the entire body, but you could select individual faces instead. And likewise, you can define individual faces or whole bodies that you don't want supported for whatever reason. We've then got a couple tabs of a few different settings and parameters that I could change if I want to. I'm not going to bother. I'll stick with the defaults. Those will work just fine. But just as a bit of a top tip when you come to trying this out for yourselves, within Fusion 360, we have what are called tooltips. So you'll see if I hover over any of these settings for a second or two, it brings up a bit of extra information, which is basically just telling me exactly what that setting's doing, how to use it. And with quite a few of them, we get a nice diagram of to help explain that as well. So it's really useful for when you're first playing about with this, first getting to grips with it and trying to learn it. it's a great way to figure out what all these various settings are doing. Like I say, I will stick with the defaults for now, and we'll give that again a few seconds to think, and you'll see that those support structures are applied now. So those have been very nicely applied between my part and the Formlabs printer platform. At this stage, if I saw something about this which I wanted to change, I could obviously come in, edit those settings, recalculate, and adjust those as needed. So at this stage, I am ready to push this over to preform, really, but I'm not going to do that just yet. Instead, let's imagine that I have done that and we have printed the part, but after we've printed it, we realize that we want to make some kind of design change. So we need a new iteration of this design. With a more kind of typical design to 3D print workflow, that would mean going back to our design software, making that edit, re-exporting that new version of the design as an STL, bringing it into our print preparation software, running back through all of the support, orientation, setup, etc., etc. Which is quite long-winded. It's down to the fact that those stages are very disconnected. With Fusion 360, because we have the design and manufacture kind of integrated with these Formlabs printers, that's not necessary. Instead, what we can do if I want to make a design change at this point is jump from my manufacture space back over to design and making a quick adjustment in here. So for argument's sake, let's imagine that this arm here was just a bit too thin. We need a bit of extra material on there. So I will make a quick direct modeling adjustment to this. So I can add some material on there nice and easily. You'll see that the sort of supporting geometry gets automatically updated as well. And nice and easy, I've made that adjustment. So now what I need to do, from my design back into manufacture, and I've still got my kind of updated design located on the Formlabs printer here. All I need to do now is simply come up to my toolbar and select generate, and it's going to recalculate everything that I've set up so far. And we can see within literally a few seconds, it's reapplied my support structures, keeping those same settings that I defined before. Obviously, I didn't change too much, but if I had gone in there and set everything up just as I wanted, it would remember all of those settings and recalculate it for this new design. And yeah, simple as that. Literally with the click of a button, it's kind of updated everything for me. And again, that's really the massive benefit of having this connected, integrated design and manufacture workflow. So at this point, I am now ready to push this over to Freeform. So all we need to do is hit this export as Formlabs file icon here. I can just select whether I want to include the support structures or not. I will do. And then I can save this somewhere local and send that over to Dan, and he can now take us through the preform side of things.
Indeed, I can. Thank you, Jack. Awesome. So yeah, like Jack said, now we'll find ourselves in preform. So as you can see, this is that exact part that he just exported to me. There's a lot to do in preform, and I won't go through all of it. I know we want to have some time for questions as well, but I sort of wanted to just show that this is how it appears coming straight into preform. All those supports he determined are there. Yeah, but now I'll just go a super quick highlight of other adjustments you can make in preform before printing. So I'll say right off the bat, any adjustment you do will delete these supports. Preform is at least smart enough to know that the supports are not part of the model. But if you do a size or an orientation adjustment in preform and regenerate supports, it will regenerate with preform supports, not the ones from Fusion. So just worth mentioning that. So in Preform, some pretty basic options, and they're mostly laid here on the left. We have size of part, so you can do down to the millimeter of actual measurement or scale from your current size. We can do orientation, and just like Fusion, if we want to make that adjustment here, we can decide which face of the part we want facing down. You can select what your base is. And then here's our support generation as well. I'll leave the Fusion ones here. We have a lot of great resources for how to use Preform out there if you're curious, but you can generate all your supports here as well as edit them individually, which is really neat. And then we have our layout function here on the left as well. So if you have a series of a bunch of different parts, the software will, if you select them all and hit layout all at the top there, it will try and organize all those parts so that they're not intersecting with each other and they'll print really cleanly. And then down here, we have our send to printer button. I don't have anything hooked up at the moment, but there's all your options. Then on the right-hand side here, we have the estimated print time, how many layers, and roughly how much volume of resin can be used. I will mention, or will be used. I'll mention that Preform is 100% free, and you do not need to own a Formlabs product to use it. So if you're on the fence about a 3D printer and want to get an estimation of how much a particular print will cost, you can take this volume number and then just subtract that out of the total cost. Well, all our resins come in liters, so it's a pretty easy calculation to say if it's $100 of resin total and I'm using 100 milliliters, it's a roughly $10 or $11 print, something like that. We also have our printability checks down here. Just be aware that at the moment, Preform does not know how to check for the printability with externally imported supports like the ones coming from Fusion. But if we look at a part like this, we can see that it would probably be just fine. So that's a really quick overview of Preform. The other thing I want to say that just to go off what Jack mentioned is if you're getting into using the Fusion supports, my recommendation for workflow would be to get comfortable with the way Preform automatically orients and supports a part first, so that you have a good idea of what works and what doesn't on an SLA machine, because there are some special considerations. And then once you have a really good idea of, this is my part, I know how I want to print it, I know how I want it to print every time, I'm going to go into Fusion and generate some supports that use a lot less material to save some money. That's a workflow I would highly recommend. Rather than starting in Fusion, coming over to Preform, I'd say get a Preform, learn this stuff, and then go back to Fusion. So I think we'll get into Q&A in a second, but before we do that, I just wanted to share very quickly the website I mentioned before. So here is the partnership website. This is the Formlabs version. There's an Autodesk version as well. I think in your invite for this meeting or in the follow-up email, they'll send a link to the Autodesk version, but the content is roughly the same. On this page, there's a button to download a free trial of Fusion. So if you're coming from the Formlabs side and you want to try out the software, see if it works for you, great place to do it. As well as this sample part that Jack mentioned can be requested here. It's completely free. We just want you to be able to feel the part in your hand to know what it's like to have a 3D printed Formlabs part designed on Fusion, which this part is. And I'll also mention, I think the person who designed this part found out it had a weight limit of like 35 pounds. So you can hang pretty significant bags and stuff from these parts with very little trouble. But yeah, that's it for our presentation, I think. And we got some time for Q&A, so I will stop sharing. And yeah, should we just go through the list, Jack?
Sure, yeah. Thanks for showing us that. I've just been trying to answer some.
Yeah, there are some chat ones as well.
Chat, yeah. Try and get around to people.
Looks like the first two questions in the Q&A list are about kind of tech specs for what you should need for running Fusion well. So
sure. That is available online. I will quickly find those. It's not particularly powerful. Most semi-decent laptops will manage with it fine, really. There we go. I'll put a, let's check.
While Jack's doing that, I can take this next one from RJ, who asked a great question. Are the same easy removal supports made for the Form 3 and Preform available through the Fusion 360 support generation? Great question. Right now, they're different supports. The way the Fusion supports would be removed, to my eye, looks like it would be a easy process as well. And the printer is smart enough to know that that's a different, it's not a different material in the supports, but it's a different level of energy intensity that's pumped into them with the laser, so they are a little more brittle. So I would say it's probably pretty close. We have not done specific tests on how close they are, but I don't think you'd run into a huge difference in the support removal process. Let's see, you answered that one about tech specs again.
Yeah, just in case anyone missed it, I put a link in the chat. Hopefully that went to everyone.
This one might be for you, Jack. This one from Rob. If you wanted to print multiple copies of a part on a single build volume, does that get set up in manufacture as well? And if so, how?
If you wanted to print multiple copies of a part in a single build volume.
Yeah, if you just wanted to duplicate the hook a few times or something like that.
100%, yeah. So within the manufacturing environment, you can create what's called a manufacturing model, which is then kind of separate almost from the design workspaces model. So the way that I would do that is create a manufacturing model and then just create copies of that body within there, and then you'll be able to fit those onto the build platform and set them all up in exactly the same way.
Couple top three there. It looks like they're all they're all good questions, and it looks like they're all for you, but I'm happy to jump in, Jack, if any of these need my input.
Sure. So that top one, does Fusion 360 include presets for recommended support size density for different materials? It does not, no. That, I think it just has a kind of standard across the board default, which is one case where, we'll be completely honest, Fusion supports are probably not as precise, good for kind of just doing general prints. If you really want kind of full control, that is where Preform is obviously expertise kind of thing and comes with that kind of functionality. I think as part of the ongoing integration, possibly something that will be looked at, but currently no. If you want,
this next one might be me actually. I think I mentioned custom supports. So in terms of custom supports, basically some people's prints will have very specific needs in terms of where supports can be placed. So if you're making like an optically clear model and you want it to be really, really polished and you don't want supports on the surfaces where you'll need to polish, maybe it's time to look into generating supports exactly of the type you need. We don't have any documentation on the Formlabs end of how to get into designing supports like we do, but if you use our printers for a little while, you get a pretty good idea of what the software is doing, and that's a good way to like figure out how to do custom supports like that. So, and then does Fusion 360 do printability checks? I don't believe it does it in the same way our software does. I think that's right, Jack, right?
No, there is a collision detection, but that's about, again, that's kind of somewhere where Preform is, a bit more expertise with that.
It looks like that one from Vibov. I apologize if I'm mispronouncing your name. Is a good one for you.
So I'm just replying to Patrick in the chat as well.
No problem. Basically, Vibov is asking, can we get all Autodesk NetFab features in Fusion 360 additive manufacturing?
Not all, no. So NetFab is still very much the really specialized additive product. Fusion 360 is starting to get a lot of that functionality in there. But some of the more advanced things like packing and the what do you call it, the latticing is kind of all within NetFab. Yeah.
Cool. Next one from Noel, looks like it's for me. I need high temp parts for thermal conduction. What process options for fabrication? So in terms of fabrication, I would say the answer from the Formlabs perspective is to print what you need. In the material we would recommend is high temp. I don't quote me on this, it's off the top of my head, but it can withstand over 600 degrees Fahrenheit. It's a great material for heat cycling and things like that, obviously within a certain range. We have tech specs for all of our materials, which will tell you things like heat deflection temperatures and elongation coefficients and things like that. Well, Jack, to answer the next question, I can go grab those material data sheets for you and put them into chat. But yeah, we have all that data out there if you're curious.
Nice. Yeah. So the next question, parametric modeling method, is it suited for all projects? Is it better to use it for a model with simple geometric modeling? It kind of depends on the geometry in a way. Yeah, it doesn't necessarily need to be simple, but I think more kind of prismatic, as we say. So more geometric than freeform, I guess. So if you remember, I talked briefly about specifically the kind of form modeling or surface modeling. There's still an element of parametric modeling you can do with those, but kind of better suited to things like sketches and solid modeling tools. But yeah, it can kind of be used everywhere, really.
Cool. Are the support generated from Fusion 360 trusted because if it fails, it's a mess? Yes, it can be an absolute mess. I would say that's why I would recommend start with the Formlabs supports and sort of learn your print, and from there, if you can optimize in Fusion, that's a really terrific way to do it. But yeah, I would say start with the Formlabs ones. That software is pretty specifically designed to do exactly that. And then once you've got a good idea of how that all works, then go to Fusion. There's another NetFab question. I'll clear that one out. Question from Hunter McCrae. And we'll go for, I don't know, Jack, you want another 5 minutes or so? Does that?
Yeah, fine by me.
That work for you?
Cool. Yeah, get through.
Great. How does the Form 3 know how much resin is in the cartridges? Great question. So it basically knows when it's new, and then from there calculates roughly how long it has been dispensing, and then uses that as a calculation to determine how much resin is left. For that reason, it's not an exact science. It's not using a weight or anything like that. But it basically says, okay, you've inserted a full cartridge, you've opened the taps to dispense resin for 10 seconds when it's 95% full. We think there is now 96% or 94% of the resin left, or something like that. The cartridge issue by quite a bit of resin. So it's also, remember, it's calculating the amount of resin in the tank in addition to the cartridge. So you'll get the empty tank warning when there's not quite that little amount of resin left in the cartridge, just because it doesn't add up what's sitting in the tank to that number. So if you get that warning, hey, you might not have enough resin to finish this print, you can often keep going and push through that anyway, and it's fine. Cool. You can take that one from Analia.
Nice. Yeah, free trial of Fusion. Does it include these new features? Absolutely, yeah. So I didn't mention, but people may not be aware that with Fusion 360, there is a 30-day free trial, and that gives you full access to everything which is in kind of the core Fusion product, which includes all of this, exactly, access to all of those Formlabs machines and all of the functionality that I just showed you.
Awesome. Also from Analia, what biocompatible material would you recommend for cell culture? How would you sterilize between uses? Any autoclavable materials? Those are really great questions. I'm not a medical expert, so I don't want to send you the wrong information. I will say we do have biocompatible resins. There's some of those dental ones I mentioned, as well as Biomed, Amber, and Clear. If you have more specific questions about your use case, please reach out to our sales team, and they'd be more than happy to connect you with a healthcare expert within Formlabs who can make sure that the printer will do exactly what you need before you buy anything. That's really important to us. So reach out to us. We can definitely go through your specific use case and make sure you're happy with. Preform question. Once supports have been set up in preform, can the model be updated afterwards without the need to redefine supports? No, not in preform. Great question. So yeah, any changes to size, orientation, the supports will need to be regenerated. And this next one looks like a feature request.
Yeah, exactly. Can we send a starter print directly from Fusion 360? Not to a Formlabs printer. No, you do need to go through preform.
Yeah, Fusion is not a slicer. It's a orientation and support generation tool. Next one is there for you as well. Looks like, Jack.
What is the difference between form versus surface modeling? So form, you can almost imagine as you have a kind of clump of solid material that you can kind of push and pull on, a little bit like having a ball of clay, say, and you can kind of manipulate that in a bit more of a free form, almost more visual manner. And at the end of it, you end up with a solid model still, just that it's been modeled in a slightly different method. Where surface modeling is just that, you're literally just getting a surface. So rather than a solid model, yeah, just a kind of infinitely thin surface effectively. So what you can then do with those afterwards just varies slightly. Hope that makes sense.
Looks like, yeah, definitely. These next two are yours, and then maybe I can take that one from Anonymous as the last one down there.
Can you specify wall thickness in the Fusion 360 additive manufacturing menus? Can you set 100% infill? For the SLA, I'm not too sure. If you're talking about FFF.
Oh, yeah, that actually might be that might be for me. Sorry, I didn't really think about it. SLA printing by default is always 100% infill because you're taking a liquid and turning it into a solid. If you want something with a specific percentage of infill, you need to model it that way before it ever gets to the Formlabs side of things. For a similar reason, you need things like a drain hole, because if you have a hollow interior, you're going to get some liquid resin in there during the printing process, and it'll need a way to drain.
Okay, but for other methods, you can set the infill, which are also available within Fusion. Next one, does Fusion have a student license? Yep, absolutely. So there are certain groups of people who can get access to Fusion for free. Students are one of those. You'll just have to go through a few steps to kind of prove that you are a student. Yes, I will. I might try and dig out some info on potentially where you can do that from. Yeah, but yeah, it does.
Well, and this last one here, can the touch point in preform be used below 0.4 millimeters because it's in beta version and the touch point of 0.4 millimeters is a visible mark on the part, which results in getting a poor surface finish? So good question. I don't know if there's a minimum in Fusion. Maybe Jack can speak to that. In preform, the reason why there is that minimum is because that is just as low as we can comfortably say for most people. And there's a risk of if it goes much lower than that, the amount of print failures that we would hear about would skyrocket. And that's a bummer, but it's just the way it works. So yeah, to some extent on SLA printing, support removal with a little filing or a little sandpaper is kind of just part of the deal. You'll never do zero supports, unfortunately. But you can minimize it. You can also minimize their placement, so it's an easier place to sand or clip off or whatever, like I mentioned earlier.
Okay.
Cool.
So one of them in the Q&A. There's a couple in the chat if we've got time. One around the if the raft is added automatically in preform once that's come out of Fusion.
Yeah, so in where you selected the lattice, right, Jack, there was an option for a build plate. So I think if you want a Fusion build plate, you should do it in Fusion. Otherwise, if you regenerate in preform, it will automatically add the plate at the bottom, what we call the raft, at the bottom of that print. But I think I saw that option in there.
Yeah, it's definitely in Fusion. Yeah. Yep. So I guess either or if you want it there. Yeah. If you know you want it, probably best just to set it up in Fusion, send it all over. Okay.
Do one quick pass of chat there. Is it possible to swap resin types mid-print? Great question. At the moment, no, it is not. Dual extrusion is super cool in FDM. It's an advantage FDM has in some ways over SLA. But no, if you're doing a Formlabs print, it is the same material from beginning to end. Cool. Should we call it there?
I think that's it. I can't see any we've missed. Apologies if we have, but I think we've done them all.
Yeah, I'm sure Autodesk will do more presentations like this. Formlabs will as well. If we didn't get to your question, apologies. We definitely will in the future, I'm sure.
Cool. There's just one question that popped up. If you've got Fusion, how do you add it in? You don't need to. Just update to the latest version and it'll be in there ready to go. So
awesome. Well, thank you guys for saying this was valuable. That means a lot. It's been a long process. So really glad you enjoyed this presentation. Yeah, thanks Autodesk for hosting this. Thanks, Jack. And
of course, yeah, thanks for joining us, Dan, and all the attendees. So thanks very much.
Have a great rest of the day, everyone. We'll see you soon.
Yeah, have a good day. Thanks, everyone.